Everything you see around you, your loved ones, your home, the mountains on the horizon, and the stars overhead, all of this is just a temporary anomaly. We are used to considering the universe eternal. It seems to us that the stars have always burned and will burn forever. That stability is the norm. But this is the greatest lie humanity believes in. The truth is that we live in a brief, incredibly rare moment that astrophysicists call the cosmic summer. This is the moment when the universe is filled with light, heat, and energy. But summer is ending, and ahead of us lies an endless, cold, absolute winter, a winter that will never be followed by spring. If we imagine the entire history of time, from the Big Bang to the complete cessation of existence as one Earth day, then the era of stars in which we live lasts less than 1/1,000,000th of a second. We are a flash, a spark in the dark. And today, we will go on a journey to where this spark will go out. We will see a future compared to which our present will seem like paradise. We will see the sun go out. We will see galaxies disintegrate. We will see matter itself, of which we are made, betray us and crumble into dust. Welcome to the end of time, to the chronicle of eternal darkness. To understand why the end is inevitable, we need to meet the killer of our universe. It has no face, it has no evil intent, but it acts with absolute mathematical cruelty. Its name is entropy. This is the most fundamental law of nature, the second law of thermodynamics. Simply put, it sounds like this. Everything in the universe tends toward chaos and equilibrium. You cannot put a broken cup back together so that it becomes whole without expending energy. You cannot burn wood and return the heat back into the log. Energy dissipates. It transforms from a useful concentrated form into useless thermal radiation. Imagine the universe as a giant wind-up clock. At the moment of the Big Bang, someone or something wound the spring to the limit. Now, 13 8/10 billion years later, the spring is still unwinding. Stars turn hydrogen into helium, releasing light. Planets cool down. Black holes swallow matter. All this is the process of the spring unwinding. We live because there is still a potential difference in the universe. There are hot stars and cold space. There are dense gas clusters and empty voids. But entropy relentlessly smooths out these differences. It strives to smear energy in an even thin layer throughout space. And when this happens, when the temperature everywhere becomes the same, the clock will stop. Heat death will come. But this process will not be fast. It will be a long, painful agony divided into epochs. And the first epoch is the era of fading, which is starting right now. We do not notice this because human life is too short. But if we look at space on the scale of billions of years, we will see the light going out. The first victim on our personal list of losses will be Earth. We don't need to wait for the disintegration of galaxies to lose our home. Our own sun, which gives us life, will become our executioner. Stars evolve. As the sun burns hydrogen in its core, it becomes hotter and brighter. In about 1 billion years, just 1 billion, that's not so much by geological standards, the sun's luminosity will increase by 10%. This will be enough to trigger an irreversible greenhouse effect. The oceans will begin to evaporate. Water vapor is a powerful greenhouse gas. It will wrap the planet in a blanket. The temperature will rise even higher, and the oceans will boil away completely. Earth will turn into a second Venus, a dry, red-hot desert with a dense atmosphere where lead and tin melt. Life on the surface will become impossible. Perhaps some simple bacteria will survive deep underground, but the era of animals and plants will end. This will be the first bell, the first act of the tragedy. In 5 billion years, the sun will run out of hydrogen fuel, its core will shrink, and the outer layers will expand. The sun will turn into a red giant. It will become so huge that it will swallow Mercury, Venus, and probably Earth. Our planet, the cradle of humanity, will simply dissolve in the red-hot plasma of a dying star. Not even ashes will remain of us. And then the sun will shed its shell, creating a beautiful planetary nebula, and shrink into a small, dim white dwarf. The cemetery of the solar system will plunge into eternal twilight. But the death of one star is a trifle. Much more terrible processes are taking place on the scale of space. Right now, our galaxy, the Milky Way, and our neighbor, the Andromeda Galaxy, are flying toward each other at a speed of 110 kilometers per second. A collision is inevitable. In 4 billion years, Earth's sky, if anyone could live on it, would change beyond recognition. Andromeda's giant spiral would fill the entire horizon. It will be not so much a collision as a merger. Stars are so far apart that direct hits are unlikely, but gravitational chaos will throw millions of star systems into the intergalactic void, dooming them to eternal solitude in darkness. Gas clouds will collide, causing the last, most powerful burst of star formation. The sky will blaze with stars being born and exploding. This will be the last fireworks display before the two galaxies merge into one giant elliptical galaxy, Milkomeda. Milkomeda will be an old, tired galaxy. It will have almost no gas left to create new stars. It will consist of old, red suns, and it will be very lonely. The fact is that the universe is expanding, and this expansion is accelerating thanks to dark energy. All other galaxies that are not part of our local group are running away from us. Over time, they will pick up speed faster than the speed of light and disappear beyond the event horizon. Imagine a civilization that will be born in Milkomeda in 100 billion years. Their astronomers will point telescopes at the sky and see there nothing, no other galaxies, no cosmic microwave background radiation, because it will stretch so much that it will become invisible. They will think that their galaxy is the entire universe, an island of stars surrounded by an endless, eternal void. They will never know about the Big Bang. They will never know about the expansion of the universe. The entire history of cosmology will be erased. They will live in the illusion of eternal stasis, unaware that their world is the Titanic, which is already going to the bottom. But let's go back to the stars. Stars are machines that turn matter into light. But the fuel in these machines is not infinite. At some point, in about 100 trillion years, the process of star formation will stop completely. The universe will run out of gas. All hydrogen will either be locked in stars or dispersed in a state too rarefied for gravity to collect it again. This will be the end of the stelliferous era, the end of the era of light. The last massive stars exploded long ago. Stars like the Sun have become white dwarfs. Only red dwarfs will remain, small, economical stars that can smolder for trillions of years. But even they are not eternal. One by one, they will burn out their fuel and go out. Imagine this moment, somewhere in the depths of space, in absolute blackness, the last star is burning out, the last red dwarf. Around it, perhaps, frozen planets revolve, on which life once glimmered. The inhabitants of these planets, if they manage to survive eons of time, huddle against this last fire, collecting crumbs of heat. And so, the fire goes out. The star shrinks, dims, and turns into a black dwarf, a cold ball of compressed helium and hydrogen. The last ray of light goes into the void, never to find an obstacle and fly forever. The universe plunges into absolute darkness. If you were there at that moment, you would see nothing. Not a single star, not a single galaxy. Only infinite, crushing blackness in all directions. The era of light, which lasted 100 trillion years, has ended. But this is not the end of time yet. This is just the beginning of true eternity. Because the time that the stars shone is just a moment compared to the time the universe will spend in darkness. We stopped at the moment when the last star in the universe went out. But this is not the end. It's not even the beginning of the end. To be precise, this is just the conclusion of a brief, bright party that we call the stelliferous era. Now the universe comes into its own for real. The degenerate era begins. This is a time that will last so long that if you write a 1 and then write zeros for the rest of your life, you won't even come close to describing this time span. Welcome to the world of the dead, to a world where the corpses of stars become the main inhabitants. Imagine this landscape, absolute impenetrable blackness. The distances between objects have increased so much that light from one dead sun to another travels for millions of years. Galaxies as we know them, beautiful spirals, shining ellipses, no longer exist. They have turned into blurred dark clouds of stellar remnants. What are these remnants? Mostly they are white dwarfs, the cooling cores of former stars compressed to the size of Earth. Chunks of matter of incredible density where 1 teaspoon weighs like a truck. There are also neutron stars, ghost cities 20 kilometers in diameter consisting of pure nuclear matter, and of course black holes. But the most interesting thing happens not with these objects, but with those unfortunates who are trying to survive in this hell. Let's assume that civilizations have not disappeared. That reason turned out to be so stubborn that it refused to die along with the light. Where are they? They huddle against white dwarfs. A white dwarf, even a cooling one, stores a colossal amount of thermal energy. It cools slowly, billions, trillions of years. For the creatures of the future, this is the ideal battery. Imagine Dyson spheres built not around shining suns, but around these dim embers. These spheres must be located very close to the surface of the star to catch crumbs of heat. Life there is life in eternal twilight. They have no day and night. They have no seasons. There is only a weak infrared heat coming from below and endless cold from above. These civilizations must be masters of economy. Every joule of energy counts. They have probably rebuilt their bodies and their computers to work at temperatures close to absolute zero because it is more efficient. But even in this dead world, disasters sometimes happen. Cosmic accidents. Dead stars do not stand still. They revolve around the center of the former cluster, and sometimes their paths cross. The collision of 2 white dwarfs is an event of incredible power. If their total mass exceeds the Chandrasekhar limit, a Type 1 supernova explosion will occur. In absolute darkness, where nothing has happened for millions of years, a light suddenly flashes, equal to the brightness of an entire galaxy. For civilizations huddled on neighboring systems, this will look like the appearance of an angry god. A burst of gamma radiation sterilizes everything within a radius of hundreds of light years. Dyson spheres will melt, cities will evaporate. But for someone else who is far away, this explosion will be a gift. It is a release of fresh matter, iron, oxygen, carbon. It is a temporary source of energy. One can imagine the nomads of this dark era traveling from one explosion to another, collecting resources like vultures collecting meat from bones. However, gravity is a ruthless conductor. Galaxies consisting of dead stars are unstable. Stars constantly exchange kinetic energy. It works like billiards. When 2 bodies fly close to each other, one of them may speed up a little and the other slow down. On the scale of quintillions of years, this process leads to galaxy evaporation. 90 and maybe 99% of all dead stars, all white dwarfs and neutron stars, will be ejected from their galaxies. They will receive a gravitational kick and fly away into the intergalactic void. Imagine the horror of a civilization living in orbit of such a white dwarf. Your star has been kicked out of the house. You are flying nowhere. Around you there are no longer even ghostly neighbors. You remain in absolute total solitude in an expanding universe. Ties with other centers of reason are severed forever. You are a lonely ship in an ocean that has no shores. And what happens to those who didn't fly away? The remaining 1% of the mass loses energy and falls into the center. There, in the heart of the former galaxy, sits a supermassive black hole. It waits patiently. And in this era, it receives the last feast. Millions of dead stars fall onto it, creating flashes of radiation before disappearing beyond the event horizon. Trillions of years pass, then quadrillions. White dwarfs cool down completely. They cease to glow even in the infrared range. They become black dwarfs. These are cold balls of degenerate matter, crystals of carbon and oxygen the size of a planet, but with the mass of a star. They are invisible. They fly through the darkness like invisible bullets. Running into such an object is instant death for any space traveler. And here, in this deep darkness, the magic of quantum physics begins to happen. Processes that in our world seem impossible because they are too improbable become inevitable over such periods of time. We are talking about cold nuclear fusion, but not the kind they try to make in laboratories, but nuclear reactions. Atoms inside a black dwarf are locked in a crystal lattice. They do not have the energy to overcome the Coulomb barrier and merge with each other. But quantum mechanics says that a particle is not located at one point, it is smeared in space. There is a tiny, almost zero probability that the nuclei of two atoms will tunnel into each other and merge. In our time, we would wait for this event longer than the universe has lived. But the universe of the degenerate era has plenty of time. Slowly, atom by atom, the substance of black dwarfs begins to transform. Lighter elements merge into heavier ones, and everything strives for the ideal. The ideal of nuclear physics is iron 56. It is the most stable element. Energy cannot be extracted from it either by fusion or by decay. It is nuclear ash, the final stop of matter. In 10 to the power of 1,100 years, try to imagine this number, a 1 followed by 1,100 zeros. All black dwarfs in the universe will turn into iron stars, perfectly smooth, cold, metal spheres. If you could shine a flashlight on such a star, you would see the beam reflected from the polished surface of pure iron. These are monuments, tombstones on the grave of thermodynamics, all complexity, all variety of elements, gold, oxygen, uranium. All this will be melted down by time into monotonous, boring iron. But the universe is preparing a stab in the back for us, a blow that will destroy even these iron monuments. We are used to thinking that a proton is an eternal particle. That matter is unshakable. We consist of protons. Earth consists of protons. If the proton is eternal, then iron stars will fly forever. But many modern theories of physics, grand unified theories, tell us no, nothing is eternal, even a proton. A proton has an expiration date. It is huge, maybe 10 to the 35th power of years, maybe 10 to the 40th, but it is finite. Sooner or later, a proton decays. It turns into a positron, anti-electron, and a pion. The pion immediately decays into photons, a flash of light. The positron finds an electron, annihilates with it, and light is produced again. Imagine the horror of this moment. Matter begins to rot, literally. The very basis of reality begins to crumble into dust. If at that time living beings still exist, they will face a disease for which there is no cure. Their bodies will begin to disintegrate at the subatomic level. They will evaporate from the inside, turning into light. Their ships, their computers, their iron stars, all this will begin to melt. An iron star subject to proton decay will glow with a weak, ghostly bluish light. It will lose mass, first grams, then tons. It will shrink until it disappears completely. This process will take an unimaginably long time, but the result is one: all baryonic matter. Everything that can be touched, everything that has mass and structure, will disappear. Not a single atom will remain in the universe, not a single electron in orbit, only a rarefied gas of photons and neutrinos flying through infinitely expanding space. This will be the great cleansing. The universe erases everything it has drawn over trillions of years. It returns to a clean slate. But there are those who will survive this decay, those who stand above ordinary matter. Black holes. When the last iron star dissolves in the glow of decay, black holes will remain the only masters of reality. The black hole era begins. This will be the longest era in history. It will last years, the number of which is described by the number Google, a 1 followed by 100 zeros. Compared to this era, all the time that the stars shone will seem like a fleeting flash, a perception error. Black holes will drift in the void like majestic whales in an ocean where there are no more fish. They have absorbed information about dead galaxies. In their depths, beyond the event horizon, the secrets of civilizations they swallowed are hidden. But can these monsters become a home? Theoretical physicists suggest that incredible structures can form around black holes, gravitational atoms, clouds of bosons that rotate around the hole, creating a semblance of an atom, but the size of an entire star system. If life remains anywhere, it will be there. Digital, disembodied life recorded in the structure of these gravitational fields, beings that feed on the pure mathematics of space-time. However, even black holes cannot defeat entropy. Stephen Hawking left us a prophecy: black holes evaporate. Quantum vacuum fluctuations at the boundary of the event horizon give birth to pairs of particles. One falls in, the other flies out. The one that flies out takes with it a tiny drop of the hole's energy. The hole loses mass. For large black holes, this process is painfully slow. A black hole with the mass of the Sun will evaporate in 10 to the 67th power of years. But the smaller the hole becomes, the faster it evaporates. This is an agony that accelerates. At the end of its life, a black hole no longer emits weak light. It roars. It ejects energy with the power of millions of nuclear bombs per second. And so, in the distant future, when the darkness becomes unbearable, the last fireworks will begin to illuminate space. These will be exploding black holes. One by one, in different corners of the universe, they will give the accumulated energy back to the vacuum. A flash of gamma rays, short and bright, and darkness again. Each such explosion is the death of an entire era. It is the erasing of the last hard drive with information. When the last supermassive black hole evaporates, nothing will remain in the universe that could hold structure. There will be no gravity capable of collecting something, no mass capable of creating something. We are approaching the limit of what science can predict with certainty. But there are hypotheses that go further, hypotheses about what happens to space itself when there is nothing in it. What happens to time when there are no events to measure it? Some models say that a vacuum cannot be empty forever, that even in a state of heat death, when entropy is maximum, spontaneous decreases in entropy are possible. Quantum leaps, Poincaré recurrences. If you wait long enough, much longer than a Google of years, then the random movement of virtual particles can create a new atom, and if you wait even longer, a new Big Bang. But this will be a different story, a different universe. Our story, the story of matter we know, is approaching its absolute zero. But before we move on to this final finale, to the moment when time itself loses meaning, we must consider one more scenario. A scenario that can happen much earlier and is much scarier than proton decay. A scenario that leaves no chance for a long old age of the universe, the Big Rip. We know that dark energy pushes galaxies apart, but we don't know what it is. Is it a constant, or is it a dynamic field whose strength grows over time? This is called phantom energy. If the density of dark energy increases, then in the future it will become so powerful that it will overcome gravity, not only between galaxies, but also inside them. Imagine that you look at the sky and you see the stars of the Milky Way beginning to fly apart in different directions. The galaxy evaporates before your eyes. Dark energy tears stars away from the center. Then it penetrates into solar systems. planets break away from orbits and fly into the cold darkness. The solar system is destroyed. But phantom energy does not stop. It becomes stronger than electromagnetic forces. It tears planets apart. Earth cracks and explodes, not from an impact, but because the space inside it expands faster than the strength of the stone can hold it. Then it tears molecules apart. Your bodies, if you are still alive, disintegrate into atoms. And in the last fractions of a second, before the singularity of the Big Rip, dark energy tears apart the atoms themselves, nuclei, protons, and neutrons. The fabric of space-time stretches to the limit and bursts. The universe ceases to exist. This is not a slow fading in the dark. This is an instant, violent death of everything that exists. The end of geometry, the end of physics. Which of these scenarios awaits us? Slow, cold rot for a Google of years, or a violent rupture in 20 billion years? We don't know. We stand on the shore of the ocean of time and try to guess the weather by the clouds. But one thing we know for sure: eternity in the form we want it, eternity of life, light, and heat, does not exist. The universe is a story with a beginning, a middle, and an end. And we are now in the best, most exciting chapter of this book. We are trapped in a burning building with no exits. This is exactly what our situation looks like from the point of view of classical physics. The universe is dying. Entropy is growing. The darkness is thickening. It would seem that the outcome is foregone. Everything we love, everything we created, will disappear into icy oblivion. But reason is such a thing that does not know how to give up. If the laws of physics tell us that we will die, then we need to change the laws of physics, or find a loophole in them. Today, in the finale of our journey, we will talk about escape. Not about flying to another planet, that's too small. We will talk about escaping from our universe. There is a hypothesis seriously considered by cosmologists such as Alan Guth and André Linde. It is called creating a universe in the laboratory. We know that our world likely arose from a vacuum fluctuation, from a tiny grain of energy that inflated billions of times in a fraction of a second, thanks to inflation. What if this process can be repeated artificially? Imagine a civilization of the end of times. They live around the last black holes. Energy is running out. But they have knowledge accumulated over billions of years. They know how the fabric of space-time works. To create a new universe, you don't need a lot of matter. You just need to create conditions under which a false vacuum transitions into a true one in a very small volume of space, but with colossal energy density. If you compress just a few kilograms of matter to Planck density and give it the correct field configuration, you can start the inflation process. A small Big Bang will occur, but it won't blow up our universe. Due to the peculiarities of gravity, this newborn space will begin to expand into itself. It will bud off from our reality. For an external observer, for the creators, this will look like the formation of a microscopic black hole. The door will slam shut, communication will be interrupted, but inside this black hole, a new, huge young world will be born, a new universe with its own stars and galaxies. The tragedy of this scenario is that the creators themselves will not be able to move there. They will remain in their dying, cold world. They will burn with their ship. But they will be able to do the main thing. They will pass the spark. They can embed information into the initial conditions of the new explosion, their DNA, their knowledge, their poems, and formulas. This scenario turns our universe into a reproductive system. Perhaps we live in a world that was created by someone else in a laboratory billions of years ago. Maybe the physical constants of our world are so perfectly fitted for life precisely because they were tuned by our parents? This is called cosmological natural selection. Only those universes survive and reproduce in which intelligent beings capable of creating new universes can appear. If this is so, then the meaning of humanity's existence is not just to survive. The meaning is to grow up, become gods, and start the next cycle. We are a link in an endless chain of life that stretches through the multiverse. And if we perish without having time to create a child, the chain will break on us. But let's go back to those who do not know how to create universes, to those who remained in the cold of the dark era. Do they have a chance for eternity? There is a frightening and beautiful concept, eternal return, or Poincaré's recurrence theorem. The universe is huge, but the number of particles in it is finite. The number of possible combinations of these particles, states in which matter can be, is also finite. It is monstrously large, but it is not infinity. But time, according to some theories, is infinite. Imagine you are shuffling a deck of cards. Sooner or later, combinations will start repeating. Same with atoms in the universe. If you wait long enough, much longer than stars live, longer than black holes evaporate, then random quantum fluctuations in the vacuum will inevitably assemble matter into the exact same configuration as it is now. In 10 to the power of 10 to the power of 56 years. Yes, that's a double exponent. A new Big Bang will happen, just like that, by chance. And history will repeat itself. The sun will be born, Earth will be born, you will be born. You will sit in front of the screen and listen to these same words. Friedrich Nietzsche called this the heaviest burden. Are you ready to live your life again? And an infinite number of times more? With all the mistakes, with all the pain, but also with all the joy? In this scenario, death is impossible. You are trapped in a time loop of a gigantic scale. The universe is a broken record playing the same song for eternity. But quantum mechanics gives hope for variability. Perhaps in the next cycle, you will make a different choice. Perhaps in the next cycle, humanity will not destroy itself, but will fly to the stars. This turns our reality into an endless experiment. We are matter's attempt to understand itself, and we have an infinite number of attempts. But what if all this is an illusion? We have approached the most dangerous line of our story, an idea that devalues both the death of stars and the decay of protons. Simulation hypothesis. If the universe behaves like a mathematical program, if it has pixels, Planck length, if it has a maximum data processing speed, speed of light, then why did we decide that it is real? Maybe the great filter, heat death, and vacuum decay are just system parameters, engine limitations. Imagine that we are characters in a complex game running on a super civilization's computer. Our world seems huge and real to us, but for them, it is just a simulation on a desktop. Why did they launch it? Maybe it's a scientific experiment. What happens if we set such and such physics parameters, or historical reconstruction? Let's see how life developed in the early stages. If this is so, then there will be no end of the world in the physical sense. There will be pressing the off button, or a server reboot, or, and this is the most interesting part, we can try to hack the system. If we understand the code of the universe, if we find bugs in the laws of physics, we can get access to the developer console. We can cancel entropy, we can make stars eternal, we can become immortal. Many physicists are looking for these bugs, symmetry violations, oddities in quantum mechanics. Maybe science is not the study of nature, but reverse engineering the code of our prison. But until we hack the code, we have to live with what we have, with the inevitability of the end. And here, on the edge of the abyss, the most important question arises. Philosophical. If everything disappears, if in 100 trillion years not even atoms remain of our cities, books, and children, if no one ever knows that we existed, then does all this make sense? Why love? Why build? Why fight for ecology or world peace if the result is one, absolute zero? This is the trap of nihilism, and many fall into it upon learning about the heat death of the universe. But there is a way out of this trap, and it lies in the very concept of meaning. Meaning is not in eternity. Meaning is in the moment. Imagine you are listening to a beautiful symphony. You know it will end. The last note will sound, and silence will come. Does this make the music meaningless? No. The beauty of music is precisely in its flow, in how notes replace each other here and now. If the symphony lasted forever, it would become torture. Our universe is a symphony. The stelliferous era is its climax, the loudest and most beautiful crescendo. We are incredibly lucky. We won the time lottery with a 1 in a quintillion chance. We were born not in the boring beginning when there was only hydrogen, and not in the dead end when only black holes remained. We live in the golden age. We see the Milky Way. We see other galaxies. We feel warmth. We are privileged observers. The fact that it is temporary makes this moment priceless. Gold is valued because it is scarce. Life is valued because it is finite. Moreover, we are the only part of the universe that can feel. Stars are huge, but they don't know they are burning. Black holes are powerful, but they don't know about their power. But you know. You are the way for the cosmos to admire itself. Without us, without observers, all this grand drama of the Big Bang and expansion would be a silent movie in an empty hall. We are the audience for whom this theater was built. Our responsibility is not to live forever. That is impossible. Our responsibility is to be good spectators and good actors. We must fill this brief moment of the cosmic summer with meaning, create beauty, understand laws, help each other. We build sandcastles on the shore of the ocean of entropy. We know the wave will come. But this does not mean that the castle should not be built. On the contrary, it is necessary to build it so complex and beautiful that the ocean itself freezes for a second in surprise before washing it away. And perhaps, just perhaps, information does not disappear without a trace. Some theories of quantum gravity say that information is indestructible, that everything that has ever happened is recorded on the holographic screen of the boundary of the universe. Every thought of yours, every good deed, every discovery remains in the memory of reality forever. Are we writing a book that no one will read? No. The universe itself is the book, and we are its authors. So what will happen when the last star goes out? Darkness will come, cold, peace. The universe will fall asleep, wrapped in a blanket of Hawking radiation, but before that, before closing its eyes, it will remember us. It will remember that brief, crazy, bright moment when on a small planet near a yellow star, matter suddenly woke up, stood on two legs, looked at the sky and said, "I exist, and I am not afraid of the dark." This was a story about the end of times. But for you and me, it should become a story about the beginning of conscious life. Stop wasting time on trifles. Stop fighting. We have too little time, and we have a too serious enemy, entropy. Let's unite. Let's study. Let's build ships. Maybe we won't save the universe, but we can make its sunset damn beautiful. Thank you for being with us on this epic journey from the beginning to the end of all things. If this video made your heart beat faster, if you felt that strange feeling called sublime horror, like this video, it will help other people find this channel and also look into the abyss. Subscribe and hit the bell. We have many more mysteries ahead. In the next episode, we will talk about what is on the other side of the mirror. Antimatter. Why does the universe consist of matter and not antimatter? Where did half of reality go? And is it possible to create a bomb that will destroy the planet with 1 gram? Don't miss it. Stay curious and take care of your light. See you.